Testing, testing. Okay, two. So can everybody hear me? Sorry, still joining. I just waited a while.
Yep, I can hear you.
Okay, cool. Okay. I don't know if we're waiting on any other people, but I can just sort of start the introduction now. So I'm George, George Kochu, and I'm an AI developer at Intrepid Geophysics. And today I'm going to be giving you guys a sort of a rundown on how we use Google protocol buffers to power the API for Intrepid. Just quickly before we start, does anybody? I just wanted to get an idea of how much have any of you guys used the task files or the batch system in Intrepid before? Like, are you completely new to it, or is it? Do you use it frequently? Just to give an idea.
Oh, we all use the job files from version 5, and I think people have really only just started switching to version 6, so I don't think people have used the task files too much.
Okay, yeah. So yeah, that's okay.
James may have done it. James, have you used the task file? I think you.
Yeah, I've had a go at using them because we've had such an old version of Intrepid installed for so long. We've done everything with job files so far, but yeah, I have converted a few of those to task files and given it a go.
Okay. Yeah, well, I mean, yeah, so we wanted to move to job files. I mean, I'll explain this later, but basically we're changing from job files to task files going forward. So if you have any questions about that, we'll be able to handle that later on. But I think everyone's here, so we can just launch into this now. Just share the screen, the presentation. Okay. If anyone has a question, just feel free to interrupt, or just wait to the end if you want. Doesn't bother me. Okay. So today we'll be going through a few things. I'll be firstly just explaining what the API does in Intrepid, and mostly explaining why we've moved on to this newer format, or the Google Protocol Buffer, and why we're trying to transition to this tool or this technology. And then I'll be giving a quick, a few examples of how you can make the task files and how you run them, and sort of some of the advantages of the job files. And I'll be demonstrating a few of the tools that you will have in order to help you build the task files, and what documentation there is available to follow when you're building these task files, and as well as tips for making sure they run if there's problems. So we'll just launch straight into it. Basically, compared to version 5 of Intrepid, we now have almost complete coverage, I would say, of task files in the system. So what this means is every single function that is exposed from the processing side of Intrepid can be accessed now using the task file system. So the reason we've done this is it simplifies sort of the communication between the visual side of Intrepid and the back end, or the engine room. So having these task files allows us to better design the user interfaces to represent what the tools are capable of doing, and what functions, what parameters they will be taking in to be used. So it's very similar to the job file in that sense, but it's just using a modern parser that has but we don't have to maintain the parsing side of things. We can just focus on adding features to the task files. So basically, task files pretty similar to a job file. We have a structure, all these blocks of messages buried within a single task. And within this block, we have several member variables, I should say. So we have the inputs and the outputs, and parameters such as a format for file. Here we've got the projection information. So basically, it's identical to a job file. There'll be slight differences in the naming convention, but mostly that's just hopefully to clarify certain things that were maybe not as clear in the job files. But it usually should be a one-to-one replication of a job file and a task file. They should match quite closely. And we're basically going to be using, well, I'll show you later on, but you'll be able to look up any of these definitions in the documentation, and you'll be able to see exactly what they are used for and what their intention was. Whereas with the job files, it was quite hard to know exactly what every variable was used for. In this case, they're quite self-explanatory, but certain variables, you might not understand what they're intended for. So when we transition to the task files, the documentation capabilities have improved quite a bit. So hopefully I'll show you a bit of that later. Yeah, again, so this is more generic as in why do we have this sort of scripting language? And it's mostly just to be a human readable messaging format so that you can understand what sort of what settings are going into the tasks. So because we could have used a different kind of messaging structure to go between the application user interface and the backend or the engine. But using this ASCII task file format, it's quite easy for people to read and understand what's happening. And you can also modify the task files as you see fit to do different functions or to change settings. And which is completely the same as what we were doing for job files. So basically, the real difference between the job files and the task files is that instead of parsing or writing our own parser, we now use the Google Protocol Buffer technology. So you can just call it Protobuf for short. And it's obviously it's created by Google, and it supports a number of languages and formats for tasks. So there's binary, JSON, and ASCII file support. It can also do streaming. We don't have any implementation of the streaming yet, but that would be a sort of like a server kind of operation. We'd be communicating with like a live system. However, we're mostly just focused on creating jobs that we can then just dispatch one at a time, or so we don't really need that streaming capability. But in the future, we will potentially be adding in support for binary communication as well. And the other big advantage of the Protobuf is that we can build this technology into multiple languages. So Java, C++, and Python are a few of those. And what this means is that users can take our Protobuf definitions, and they'll be able to build their own apps or their own scripting controllers based on our Protobuf, which I'll get into a bit later. So when I was mentioning the definitions, basically we have these .proto files, and we ship these with Intrepid. And these go through all of the member variables that are in each task file or in each task file message. And this is just like a declaration of all the parameters that we want to have available in a certain message. And this is what's been parsed by the Google Protocol Buffer compiler, and that's what builds these language bindings that are going to be used both within Intrepid, and that could be used by you externally if you want to programmatically control the task file generation and automate that as your own sort of, you could use your own program to run Intrepid effectively by linking against these Protobuf definitions. So we can see here that it's pretty much quite simple. We can just declare string types if we want to input a name, like a file name, into the input, and we're just declaring a number of variables and assigning a unique identifier to them, which isn't, you don't really need to know about how to create these messages because they will be done all for you, but you can read this and understand, hopefully, that what these are the variables that are available to you in this task file. So these proto definitions are actually in the extras area in the installation. So if you get a chance to have a look at that later, I'll also show you later, but you can view all these definitions there. So basically, the reason that we've got these protocol buffers is, again, we wanted to create an easy way to link between our GUI and the engine. So because of this, we can actually already ship Intrepid with a number of these bindings, which means in terms of Java and Python programming, there's already pre-built bindings that would let you immediately use this sort of scripting, or like advanced scripting technology within your own application. So my colleague Diffu Wang will be talking about this later on, but you can also take the Protobuf bindings that we're shipping, or I say the Protobuf definitions, and you can build your own bindings for whatever language you intend to use it on. This is pretty advanced, so it's not at all necessary in order to use a task file language. I'm just trying to give you guys a sort of a the reasons why we've gone on to this technology. But we're still preserving all of the old just basic scripting functionality. So you don't need to worry about, you don't have to understand all this, all the bindings and things like that. It's totally optional. Just want to make that clear. But this is just an extra thing that you can now do that the job files couldn't do, because there's no way to expose sort of the parsing and the writing of these tasks, of the job files, to the user before. So hopefully that explains a bit about why we've moved on to the protocol buffers. Does anybody have any questions so far? No? Okay. It's all right. So I'll just, next we're sort of going to move on to maybe what we might be more relevant, just how you use the task files within Intrepid. So basically, we have our user interfaces, and the user interfaces are what are generating typically. You might not see it happen, but we are passing, again, all of our messages go through the task files and then into the engine. So usually we have a module that is specifically just for taking in the task files, and that distributes the different messages in a task file to the relevant tools that we're processing the job, basically. So I can quickly show you guys what I'm sort of talking about here. So here we look at the project manager, and we don't have any. This actually doesn't touch any of the engine room. This is just a user interface that is capable of creating a task file and then sending it to a different executable. So if we launch an app, all we're doing is bringing up a Java GUI. It doesn't have any actual connection to the engine. Everything it's doing is just this whole GUI. All it does is it creates a task file, and that's what's been shipped off to the engine. So, for example, we can. I'll just open up a different job real quick. So any of these tasks here, they are demonstrations of what would be created by the GUI. So I'll get back to that in a second. Basically, to run these task files, we can start with, I'll just skip ahead one step. So there's 3 different ways that we can use the task files, which is a little bit different to before with the job files, where you'd simply just execute them in the batch system. But now we have the ability to take a pre-built job file or task file and then load it up into the GUI. And then we can make changes to the task file there and then execute it from the GUI. So just for example, I'm in the project manager in the examples area of the installation. So this might be a slightly different structure to how you're used to it in version 5, but we have the underneath the installation of Intrepid in the sample data area under examples, we have a number of task files that you can sort of use to experiment with, and just to learn about how we structure the new scripting language. So under the gridding area and the grid operations, here we have a number of tasks that we're using for grid op, which is grid operations. And we can take any of these task files and we could open them with the GUI using the Open with Task button. And this will load it into the actual GUI. So it's taking all the settings from the task file and it's populated the GUI automatically. So this is what allows you to recover a sort of a state that you, like whatever state of the job you're up to, you can go back to it using the task files and reproduce whatever workflow you were using or whatever settings you had. So if we wanted to, we could just run this task file now, and that would be fine if we want to. But however, we might want to make a change. So if we just change any part of it, that should be, oh, I didn't expect that to happen. Sorry about that. Try that again, different file. Sorry about that. We'll have to figure out what happened there. So again, if you wanted to change, you know, a file that you're using, you can do that here. It's not really, it doesn't really matter. You can change anything you want, and you should be able to then save the task file. So it says it's changed it, save the name to preload GUI 001. There it is. We've got our new task file. It's got the new changed name. So sort of the advantage of the task files now is we get this back and forward action. Every time you change something, you'll get a new copy of your task file with the new settings. Now, I wouldn't actually want to run this because it's not going to work. The name's changed. But we can always just reload the original task file using the Open Task File button, and reopen the original job, and that will reset our GUI to the correct state. We can click Run, and it should create our new tensor grid, which it looks like it has. Just keep in mind, I'm not trying to teach you guys how to use GridOp at the moment. We're just sort of explaining the task files and how you can use them. So basically, most of the new GUIs will support this feature with preloading a task file and saving them. However, the older tools are still to be completed in that sense. So the old style of the import, the export tools, they won't have this functionality as of yet. But that's what we hope to improve later on. We're going to be going back through all the old tools and revamping them to use the new style of the GUI and to have full compatibility with the task files. However, I will mention that the task files will all work with the engine side. So all of the functionality is exposed already on the engine side, but you may not be able to take advantage of the preloading of task files at the moment, just because some tools haven't been updated yet. So yeah, that was basically, that's the simple way to use task files. However, if you're more interested in just manually changing the actual file itself and then running it again, there's another way of executing these task files. So the project manager will allow you to open up any file that you want. You can just right click it and open with your registered app, which registered app just means the editor that's assigned to this file type. So here we get the same file, but we can just manually make changes. So just like a job file, you can type in whatever you want just to make alterations. If you just want to change, the output name, you can just do that here and save the file. So it's the same as the job files, and you can run that directly. You don't need to wait to open it up in the GUI like here we were doing before, but you can just simply make a small change, right-click the task file, and then click Run, and it will do the exact same thing. and now we've got our new output. So very similar to the job files in that regard. I'll also show you more of the, if you're interested in the scripting side of things, you wouldn't be using the project manager to run all these task files. So in this case, what we would actually be doing is using like a command line message to call up the task files. So we're in this directory and we want to get to the command line. We can just go into File and open a new command window. So this is going to have a, this has got a predefined environment that should link to all of the executables that Intrepid offers. So basically, for running most task files, you're just going to be using a single executable. It's called fmanager, which stands for file manager. And this executable is what's driving almost all of these task files in the background. It's what the user interface tools will be calling as well, but here we can do it manually. We can just do skip using any of the GUI parts. So the commands to run task files, it's very simple. We just type in hyphen batch, and then we can add in the name of the task file that we want to run. So in this case, it's the grid up underscore create tensor. I'm just going to complete that, create tensor task. So this is just the really bare bones way of running any of the task files. It's exactly the same as how the job files would be run in the batch as well. It's just if you wanted to be doing, if you wanted to use a scripting, like a batch script outside of the, a Windows batch file to actually run all these are the commands that you would be using to execute these tasks. So yeah, that ran without any issues. It's pretty simple. There's a lot of other functionality as well you can find in the batch window, but that's sort of more for querying data sets and getting statistics and things like that. It's not really related to the Protobuf, but I could see that you would want to use that if you were building an app or a sort of a script to test out how the outputs change. You can always use the scripting language to extract the stats information from a grid, for example. So basically, they're the three main ways you can run a task file. I'll just go back a step and we can talk about creating these task files in the first place, because if you're not familiar, if you've been using job files for a long time, then the task files might not, make a lot of sense. So what I would recommend is the easiest way to get used to it, obviously, is just to use the GUIs to specify your jobs initially, and then use that to create a starting point. Export the task file from there, and that will make everything a lot easier. Writing from scratch is going to be quite challenging, so you've got to make sure you understand exactly how the members or the messages are structured within a task file. So here it's quite simple. You just got your Intrepid task, and then there's a single level for the tool. It's just the grid op tool, and then you've got all your parameters. But it can get a little bit more complicated. If you look at like a task from the gridding area, you'll see that there's multiple levels of members, and it's kind of hard to grasp why it's all separated like that and how it's ordered. But so that's why I'd recommend always using an existing task file and just building off of that rather than trying to write it all yourself manually.
Can I ask a question, George?
Yes, sure.
Yeah, so would another way of doing it be to go, like say you do a process by going to the GUIs and putting in the parameters that you want.
Yep.
And then you go file, log files, and then you can see the file, the task files just being created.
Yes.
Do the log files make task files, or can we do it that way? Or
So the log files usually, I mean, if you mean the running logs, they don't usually hold. They might hold part of the task file. We do get a history report.
because is there a way to actually, do the process and have it record into a task file so that we can do it that way?
It's kind of like it does do that for you. There's no, like, you don't start a sort of like a macro recording session, but when you do run some of the new GUIs, you are getting, in effect, a history report. So if we did, for example, we want to start from scratch. So we've got a grid here, and we take the projection conversion tool. It's been reworked. So what we do now, these actions that I'm taking, they're going to get recorded effectively once we run the task, or we could simply just save it at this point. So we want to reproject this grid. If we click run, it's going to generate a task file in our working directory, and that will save the settings of what we've just done. So in that sense, we get a bit of a history.
Okay, so I saw, in the GUI there, you can go file, save task file as.
Yes, you can also.
And you can do it like that. Okay.
Just under file and save task file. Just give it a new name. So you don't have to run it, but yeah. So there's two different ways. If you run it, you'll generate the task file usually as well. I know we want to use this history file here to also save all of the jobs that have been run, but it doesn't guarantee that you're going to get task files out of it, unfortunately. Sometimes it's still using the old job files, but the history file will also show what's been executed sort of in the order that they've occurred. But it's probably, if you just want a specific piece of the process, then you can just save it out of the GUI. Yeah. Does that explain everything?
Yeah. Yep, that's fine.
Okay. Does anyone else have any questions about creating the task files?
Yeah, I did. Were you saying that not all of the tools currently work with the task file?
Yeah, that's correct. There are some of the older tools, like when I say the tool, I mean the GUI side of it. The engine side's fine.
Okay.
But if we go into the import area, because it's a very old user interface, you can't actually preload the tool by just opening the task. You might get a half complete. Yeah, didn't really like it. So there's certain things you can't really do. We're sort of still going through replacing some of the tools. But anything that uses the new Java GUIs, which you can, like, say these grid operations, projection conversion, a lot of the modeling tools, which are pretty new, they all use the new GUIs. They all run with the new task files. It's all native. Yeah, so it's not everything. It's not fully covered yet. So we're still working on that.
It looks like there's an example though for all of the tools in that example folder. They're just not all of them will work at this stage. Is that right?
That's correct.
Okay.
But by in the GUI, they might not all work in the GUI, but they will all work if you just run them manually. They're guaranteed. You can just run most of these task files. So even though, the clipline GUI isn't updated yet, you can still execute the task files just like you would a job file and get the correct results. Yep. So
Okay, so for the clip one, if we want to write a task file for that, we're better off, getting that task file example and modifying that.
Yeah, that's a good.
Rather than doing anything through the GUI.
Yes, I would say for certain tools, yeah, that's true. It's just because they've never really they were built around the old system of the job files, or they were directly interfacing with the engine room. They didn't have this sort of glue in between. So everything that they were never really intended to use the task files. So we're reworking most of the GUIs, and yeah, it's just an ongoing process at the moment. Yeah.
Okay.
I've got a question as well as Matthew here. I've used the job files before, and now looking at some of the task files, I think you mentioned before they are quite slimmed down. They don't look like they've got as many parameters, etc.
Okay.
And earlier in the presentation, you showed an example of gridding, and you had the task file, and then you had another file that you said was stored somewhere else in an Intrepid directory. Could you just explain that to me again?
Yes.
And in context, if you wanted to run a grid operation, but you wanted to specify a particular origin or something like that, looking at the grid task file, it didn't look like it had those parameters included in it.
Okay. So in the gridding area, so these task files, you don't actually need to have every parameter inside them. There are defaults. So if we just reopen this one. So we do have the origin here for this case, but
Okay.
you're not required to specify every parameter. So the task files will allow you to leave certain variables empty, and it'll just use the default or figure out the correct parameter to use. If you want to know what the defaults are, then I'll just can quickly show you. We have it's sort of like a user, like a help system. Well, not a help system, but the definitions for all of these member variables and their default values are available in the Protobuf documentation. So
Good.
just bring that over. Sorry. So if you go under the help to the Protobuf definitions, you'll get a list of all the the tools. So we want to go under the Intrepid, and then we can go to the gridding area. Sorry.
It's okay.
I don't know why it's not showing up. Sorry, I'll just have to. Sorry, it's that one. So we got the gridding Intrepid main method, and then this sort of tool or this module depends on a number of other methods. So if we go through each of these sort of sub methods within the gridding tool, we can see all the default values that are applied to each variable. So there's only a few variables that would be required to be used. All these are optionals, so you don't need to include them in the task file if you don't want them. However, if it's required, then you would have to use it. Otherwise, all the optional parameters have a default value, so you don't need to necessarily assign those unless you want to change it from the base behavior.
Okay, great, thanks. And there's probably some advanced options that you can switch on using those parameters, I take it.
Yeah, we should mostly have everything fully. Everything should be in the GUI, at least for the gridding. We can open up the gridding task here.
So there's a couple of things that I've had a bit of trouble with the extrapolation values,
Okay.
that sort of thing. But that's okay.
They're not getting carried across.
Deal with that another time. Yeah, they're just funny the way it works. That's okay. We can look at that another time. Thanks for that.
Yeah. I mean, if it's not an issue, we don't know about it at the moment, then we would want to get an email about, or a support request for sure, if there's things aren't working. But yes, for in this example here, we can actually preload the GUI with the task files for the gridding. So that was a recently added in feature, I believe. But yeah, it's you know, I definitely recommend you use an existing task, just because it's quite hard to understand exactly what's going on. Just use the documentation as like a sort of you know, as a crutch if you don't understand what a value is being used for. Most of the variables have a comment attached to them, so you should get an idea of what they're used for. They're not self-explanatory.
Thank you.
No worries. So we've been through this. So it's similar to job files. You can, of course, just append a new task file to the end of an existing task file. So if you want to set up a whole bunch of processes to execute one after the other, you can just add those into the same file and then execute it as you would normally execute a custom script. So just keep in mind, if you do take multiple files or multiple modules and try and run them at the same time, you will have to use either the right-click menu in the project manager, right-click run task file, or use the batch command line fmanager, you know, -batch and then the task file. Just because the GUIs themselves, the individual GUIs won't be able to handle multiple modules, or I should say alien modules, because it's not built to parse in those.
If you've already got, if you've already got complex job files written, which I know some of the people at GA have got these great job files written.
Yeah.
Are you able? We've sort of tried. I personally tried unsuccessfully to use the turn job into task file functionality.
It's slightly limited. It can't cover everything, just because we've either restructured how we want to change so certain name changes have occurred from the transition from job files to task files. So the convert, just so everyone knows what you're talking about, we do have a function to convert job files into task files. However, it's really not, it's not a guaranteed one-to-one conversion. So for example, here we've got a grid up.
Is that something that?
Sorry, yes.
I was going to say, is that something that Intrepid would be prepared to help in GA with, if GA would supply Intrepid with a job file and say, look, we'd like to convert this job file into a task file. Would you be able to help with that?
Yeah, I think so.
Great.
We can definitely help with that.
Yeah, thanks for bringing that up, Matthew. Yeah, we do have a lot of job files. We've been using the software for a while, and we have some job files that are very well written, and it would be great if we can just have, you know, if we were able to convert it straight to a tax file, and even if the majority of it is converted and then we just have to add a few things, that will be very helpful.
Yeah. So we do support, it's to an extent, it's not perfect, but so here we have a job file, we can right click it and we can use the convert job file to task file feature. So, you know, the success, so it looks like it's mostly got the settings in there correctly. We can just open up both of these. We can just try running them both, I suppose, and see if we get the same result. So the job file, let's do that one quickly. Apparently its data isn't in the right spot. just try a different one. Go find a job file that's actually functional at this point. No, I think the data sets have moved. We can just quickly do that one manually. I'm just going into the data sets area, copying over a grid. So here we have the rotate job. It's looking for this M level grid. Couldn't find it before. I'll just quickly change that guy. Just this. Okay. So we can run the job file. It seems to be working. So we'll just try now converting this old job file into a task file. I'll just delete this one before we do that. Just so we know it's got a new one. So convert this job file. We know that works. So now we've got the converted task here. I'll just change the name of the output just as an example, so we don't overwrite our existing output. Sorry. And we should be able to run, hopefully, if the conversions worked correctly. Okay, so we do have an issue already. So it looks like the grid op name has changed, but it hasn't been correctly or translated between the old grid op name and the new grid op name. So I guess as you were saying, yeah, we do need to slightly improve this area. So it had the case was wrong in the grid op name, so we should be able to change that. So there are going to be small errors, I guess, that you would have to fix in most of the new converted tasks.
Yeah, look, I think that GA will be really appreciative if some of those jobs can be converted into tasks.
Yeah,
with a bit of help from Intrepid.
Okay,
That'd be great.
Yeah, I agree that it's quite a tricky. Well, it's quite frustrating if you want to preserve your old job files. Yeah, if you can point out specific areas where it fails, I know there's still clearly some that we need to get. So yeah, we'd appreciate if you give us examples of the jobs that you need converted. We can try and improve that tool a bit more.
I think it's actually good timing, Yvette, you might agree, good timing over the next few months to get that sorted out.
Yeah, definitely.
Yep, sure.
So yeah, I just would also point out, I suppose it's a slight shame that it's not converting correctly, but at least with the new files, you do get meaningful parsing error messages. So you can hunt down all of the misspelt words. So in this case, it's looking for a word, output precision, which doesn't exist anymore in the grid operations, because it's probably a file or the output type now or something like that. So the new task files will allow you to hopefully find the parsing errors a bit faster than with the job files, which were a bit more silent in how they failed. So that is one of the advantages of the task files. So yeah, I was talking about just the combined task files. So we're just going to have a look at this example here under leveling. So in this case, we've got a few different tools that have been run. So we've got split crews, and then we have marine level at the bottom. So you can't really preload the GUIs with this task simply because there's multiple GUIs. So in these cases where you've got a workflow set up with all these different functions, you will need to use the run task file option. You won't be able to adjust the settings in this case. So that is a limitation. You can't you can't go through each of these blocks and edit them in the GUIs. It might open the first block in the task file, but you won't be able to see the other settings for different tools. So that's just something to keep in mind when you're trying to combine task files into a single script. So yeah, some other features. If you want to do repeat blocks, I know you can do them in the job files. It's the same deal with the task files. You can assign a number of variables or a changing variable in this array here. So we've got this array called from, and you can set in a number of values inside of this sort of array, and then the repeat block will rerun through whatever tasks you have specified, substituting in these values each time it runs through. So that's just a way to run through multiple data sets or combinations of data sets at the same time. So the only things you need to change in your task file, which you have to do this manually. There's no tools set up to create these repeated tasks, but you use a $sign and then the variable name that you've defined earlier, and that will just substitute in the changing variables each time it runs through. You can also have repeat blocks inside of other repeat blocks if you want to try, multiple combinations. So you can quite quickly run through a whole bunch of parameters just by stacking these repeat blocks within each other. Does anyone have any questions about that? It's sort of complicated, but there should be some examples in the examples area of the installation where you can have a look at all these different types of the combinations of task files.
I think most people have done repeat jobs already here. Okay. I think everyone's run a repeat job. Adam, have you run one yet?
Yep.
Okay, that's good. So yeah, it should work just like it does in the job files. So shouldn't be any issues, hopefully, coming out of that. Now, I did show you earlier on in the presentation sort of like a snapshot of the how we define all these Protobuf, all the new member names and things like that. So if you are interested in writing your own sort of task file writing implement and driver for Intrepid, then there's an area inside of the installation where you can access all of these Protobuf.proto files. So it's just under the installation in extras and Protobufs. And this carries the raw source for these definitions. So we can go back to the Intrepid tasks area. And this is just like this is what gets compiled into Intrepid every night. And these are all the definitions for each tool. So here we have the survey distance tool, and it's got all of its variables here laid out. So this is replicated in the documentation, but you would be using these proto files if you want to rewrite your own, or if you want to use some scripting in another language like the Java or in Python, and you want to build the bindings, you'd be taking all these definitions that are here and using them to construct task files within your own program, and then sending those you can then send those task files to be executed in Intrepid. So my colleague will be talking about that next, actually. Mainly focusing on how you can use Python to script or create scripts automatically. So he'll be joining you in about 5 minutes. So if you guys want to just, you can ask some questions, or if you want to take a break for 5 minutes, that's fine. Yeah, but that would be pretty much just an introduction to all the features of the new task files in Intrepid. But yeah, if you have any questions or you want to take a break right now before the next segment, yeah, just go ahead.
Just because I'm a bit slow,
Yep.
could
Sure.
you just explain a little bit more detail about what we were just talking about, the Protobuf definition files?
Yeah, sure. So basically, these are the the Protobuf definitions. You don't need to use them to write the task files manually or anything. They're sort of, you can just use them as a reference if you're trying to find like a variable name or a tool and what parameters that tool takes. That's all the definitions show you. The definition is simply it's like a structure, a known structure that's going to be used by the Protobuf compiler to build the parsing or the parser necessary to run the task files or to read a task file. It's just like the definitions are just a map. They're a map that allows you to, yeah.
So this is the survey distance. So if there were some default values that if you sort of saved out a task file and you didn't see every parameter in there,
Yeah.
If you referred back to the definition, the survey distance definition, all the parameters would be listed here.
Yes.
You could, and if there was one that didn't appear in your task file, you would be able to put it in there if you wanted to.
Yes, that's correct. So you don't, it's not guaranteed that you're going to see all of the variables every time you export the task. If you don't change a variable in the GUI or something, it may decide it can actually just omit that from the task file because it's a default. If it's a default, it will just skip it effectively.
If you come back into this definition file, it will list every single parameter that is an option.
Yes, absolutely. Yeah.
Thanks.
If it's not on this list, then it can't. It won't accept it when you try and run the task. So it's
Just while we're here, could we find that definition file for the gridding tool?
Yep, sure. So it's a little bit more complicated because the gridding tool uses these sort of modules or extra messages within the message. So you have for example, here we just have the top level of the gridding tool, but it clearly doesn't have all the features from gridding. So for example, we've got the grid refinement module or message within the gridding tool. So we can follow this grid refinement area and we can look for, that. And so here we have the message for grid refinement. And this is what's going to have all the smoothing iterations and things like that. So it's the idea behind splitting up all these modules is, it's for modularity. So you want to be able to reuse these components or these messages within other tools where possible. It's not guaranteed that they're going to be reused, but you will find in some cases like the projection information message will be reused in different tools. It will have the same structure, and that's simply because there's one definition of the like a message for projection information, and then we can reuse that in different in all the other tools, and we can refer to it.
I noticed you had diffusive trend gridding back on the screen previously. Is that something that's being added back into Intrepid? The diffusive,
right,
that 1944.
So, yeah. I couldn't comment on that. I would have to ask. Probably have to ask Des if we actually support that at the moment. But I would say there's no guarantee. The feature might be there because we intend to implement it later,
Yeah.
sort of reserving the space, but it's not necessarily going to be available. So
It's one that was in and then it was out again. So I don't know. I don't
yeah,
know the full
we might have
history
had
of it, but
trouble with reliability or something, and we decided it wasn't feasible to keep it going or something. Yeah, I'll need to ask. I actually need to ask someone else, I believe, to figure out if we are going to be supporting something like that. But thanks for pointing that one out.
no problems.
Yeah. So does anyone else got any questions? Yeah. Well, everyone might still be on a break, but we can. I'm going to let the next presenter know that you're all here and ready. So that will be pretty much everything, I believe, for now. Yeah, I think the session will be restarting in a few minutes with Diffie1. And he'll be going through all the Python, how to use Python to write your own task files effectively and execute them in Intrepid. Okay.
Thanks, George.
Yeah, no worries.
Thank you.
Thanks, George.
Oh, thanks a lot.
Thank you.
Hopefully it was instructive.
5-minute break.
Yeah, different.
Yeah, I'll do it.
No.
The reason, so in and out each other, we still ran. We're on down.
Oh yeah, but it's still going.
Yeah, yeah,
I know you're coming. Yeah,
I can see myself.
Just getting going.
Right. No problem.
it's on the
Can you see here for a few, if I got trouble? We can practice, leave it social distancing. No problem with that. All right. Okay, good afternoon, everyone. So can you guys hear me?
Yep, I can hear you.
Yeah, thank you. Thank you very much. Okay, my name is Difu. I'm a software developer for Intrepid3D Physics. So for those people who know me, I've been working with Intrepid for more than 12 years. Okay, so today I'm just going to give a short introduction into the API, the Python bindings of the API side. I think this has become a quite hard area because let me just get started. Okay, so if you have questions, please feel free to unmute yourself and ask. You can interrupt me at any time you want. Okay, thank you. So let's begin. Oh, geez, important notice. I'm not going to read this paragraph. This makes me remember a big red FBI warning type of thing. Okay, now I think George has given a short introduction into the protocol Google Protobuf buffers and what kind of role it plays in Intrepid. And now the Google Protocol buffers now becomes the core technology to glue our libraries and applications all together and to become a kind of a tool not only for developers but also for users and to get access to our algorithms and tools. Generally speaking, you probably see this flow chart, maybe slightly different, but it doesn't matter. So we captured all the routines, algorithms, and processings into protocol buffers. So this is so-called the .proto definitions. And this is a kind of interface definition language where it can be turned into different language bindings. So by using the ProC, so-called the protocol buffers compiler. And George probably introduced there are different kind of languages, or there are plenty of languages are supported. So for example, C++, Java, and today I definitely will specifically focus on the Python bindings. So generally, from the the .proto definitions, this one is part of our software, and we ship it as a part of the SDK with the software package. Or you can find these .proto definitions on the internet. We created a project on GitHub, so anyone can download the .protos and then generate their own language bindings by themselves. For third-party applications, if, for example, if you want to integrate with Intrepid, or you want to interact with Intrepid, we used to have these Java files. We used to have the SDKs with the C++ SDKs with headers, and you have to compile your code and link against our libraries. And now for these third-party applications, you can use this ProC generated Protobuf bindings libraries to generate the task files, and then send the task file to fmanager, which acts as a kind of dispatcher type of things. And fmanager will find the right, the appropriate Intrepid subroutines and executables to execute a certain task, and then get the output back, feed it back into your application. So this is pretty much a tool to help not only users but also developers and to integrate several tools together, or to try to do some complex things. Yeah. So let's just move on. Okay. So just give everyone a little bit head up on the history of the Python bindings. Intrepid has been using the Protobuf technologies for many years, and up until recently, we have more and more requirements and requests, feature requests from our customers. They raised the question, well, how can we access to Intrepid's core functions, not from the user interface, but from another software package, or can we play with the core functions? Can we play with the algorithms? And we said, oh yeah, well, in order to expose what we have, and it's because now Protobuf plays a key role in H2, and H2, George probably introduced, H2 now has an interface, a Protobuf-based interface, where you can just throw in a Protobuf-based text message to the tool, and then the tool will try to parse it and then run the job. So we say, oh yeah, well, why not just simply generate a Python package and then open the Python package to the customer, so that the customer can use the Python programming language to write your own tasks or write your own scripts. And from our insight, you're probably not quite interested in that, but this is very important for Intrepid as well. So Intrepid, internally, the team now is using the Protobufs and the Python bindings and that kind of things to do tests and to test the routines and to try to integrate several software packages together. And also, this is a kind of an effort, to decouple the component and to improve the quality of the software. And now we need a technology that can, to loosely couple the components altogether, instead of the old-fashioned libraries, dynamic linkings, and that kind of things. And Python is I'll probably just jump a little bit. Python, the reason why we choose Python here is Python is a programming language. You heard Joe said, well, the interface itself, the task files is a text file, but a text file is not a programming language. It's not a scripting language. It cannot, the functions, the features are very limited. It has to be well designed to describe what you really want. But well, in that case, it never can, compete against a real programming language, a scripting language. And Python is very, popular in both scientific education and industries because, it's quite easy to use. You don't have to compile that, and it has a very rich libraries. And well, as a kind of glue, language, glue technology, and Python is very friendly, to different programming languages, so that you can, put the libraries all together. And the Google Protobuf, by using Google Protobuf technologies, and the Protobuf, because well, this is the interface definition language, we use the Google tools to generate the language bindings. And currently, it supports a wide range of programming languages, say, for example, C++, C#, Python, Java, JavaScript. And so you can use the ones that you want. Say, for example, if you're developing a web application and you want to talk to Intrepid, and because Intrepid has a Protobuf interface, so you can use the .protos and utilize the Google Protobuf compiler to generate the JavaScript bindings, and then you can start to write your own tasks or write your own scripts to drive the Intrepid functions, audio model. And compared to the old jobs and tasks, as I said, well, there were some things that I really hate, I really dislike in the old jobs and task files. One important thing is the repeat blocks and that kind of things. Well, in the text file, it's from a programmer's point of view, it's a little bit odd, to define a repeat block like this in the jobs and task files, because the meaning of that sort of things is very, very ambiguous. And but utilizing a programming language, so you can easily define a table or a map and put the variables in a loop, and then to generate a bunch of libraries, a bunch of tasks just by yourself automatically. And we provide this Intrepid. Also, there are a lot of other benefits of using Pythons. We provide the Python bindings as a reference implementation which means this, as I'll probably mention later, which means this Python library, Intrepid batch library, is not mandatory. You can use the one invited by us, or you can just simply use the Protobuf and then to generate your Pythons. You can also, you don't have to use our, I'll say probably, I'll talk about it slightly later. And just talk about the library itself. And currently the Python library is implemented and uploaded to the pip repository. So it can be installed and uninstalled using pip. So I'll show it later. So well, if you install the Python library, the Intrepid batch library using pip, it'll be available across the system. So anyone who is using the computer can have access to the Python bindings. And instead of writing the task files by yourself using a text editor, you can use Python, the APIs, that kind of things, to help you authorizing the tasks. And one of the great things is because it's a programming language, so you can use any IDEs that support Python, like Visual Studio Code, to, well, as soon as you got the Intrepid batch library installed on your system, you can use Visual Studio Code to start to write your Python tasks, your Python scripts. And the Visual Studio Code, the IDE, the development tool, will allow you to, so will provide some features like, auto completion and syntax highlightings and the kind of things. Well, this is something that's the, traditional text format or binary format or even JSON, sort of things the text editors can't, provide. And in this library, we also provide a kind of optional, executor class. So this is a very simple class. It just simply knows, well, from your Python script, because you can just simply, call the execute method in these executors, and this executor will set up all the environment of Intrepid and that kind of things, and then we'll execute the task files. Let's move on to next. Okay, so I'll just give you a little bit head up these requirements. So the Python libraries requires Python 3.6 plus, and the current, I think the latest version is Python 3.8. We tested these sort of things regularly on 3.7, so it should work on 3.7. And because it's now hosted on the pip repository on, it's not in a pip repository, it's on GitHub. So, so you can install using pip directly from GitHub. We provide two links here. The first one is using SSH. The second one is using HTTPS. I personally prefer the second one because in order to get access to GitHub through SSH, you have to set up your private key pair. You have to upload your SSH key. But for HTTPS, because this is a public project, so you can just simply do it straight away. And using pip, it's easy, just some basic Python stuff. You can uninstall the Intrepid Protobuf anytime you want. And during installation, during pip installation, it'll pull in all the dependencies like the Google Protobuf libraries itself, and this is not our invention, and some other dependencies. So it's a lot easier. That's why this Intrepid batch library is not included in the Intrepid shipment. So you won't find it in on your disk in an installed version, because we keep improving that and we keep updating that. So just you can use pip to upgrade to new versions. And here is this is a very simple example of the Python script and the corresponding task file. I think George has already showed everyone many task files, and across the whole during the whole training sessions, you'll find the task files being intensively used because the task files is a bridge between packages, is a bridge between human and computers. Definitely you can access to the software through the user interface, but for experienced users, they keen to have a scripting or a batch system, which can help them do their job more efficiently. So this task file on the right side, so you got it. So for example, this is a clip line type of job, and you have an input file and all the fields and the line type, quality, X out, Y out, minimum separation. And well, if you have a little bit experience with modern programming, you probably noticed that this file looks quite similar to JSON format, but different. So this is a traditional ASCII, not an ASCII, it's a UTF-8 task file, which can be parsed by our parser. And I would say the JSON format should also be supported, and we can support that. But in the version that you have for today, you have to use this text format. So one of the key differences is these parameters, these attributes, they're not quoted in double quotes. This is a key difference. But well, let's focus on the Python part. But if you have a look on this script itself, so after you installed the Intrepid batch library, and you should be able to import some of the libraries. Say for example, from this Intrepid, import master task bb2 as master, and from Intrepid utils, import executor. And then after that, you just simply set up all these parameters. So you can do whatever you want. If you have multiple ones, you can run them into, you can define variables, you can build a loop, you can do whatever you want. And this batch master, this batch job type thing is the root element, which aggregates all the Intrepid tasks and different kind of tasks. So here, as an example, we add an Intrepid task. So this is an Intrepid task. We add it to the batch, and we set the clip line method. So this clip line, we give it input file x, y, blah blah blah, and this logging just for debugging purposes. And the last statement, execute batch, will just simply run this job like what you did. From command line, you run fmanager dash batch, and followed by the task file. And here you don't have to run, you don't have to save this sort of thing into the task file, you just simply run it. And this logging.info will print out the task file on the screen. So if you want to save it, say for example, for future use, you can just simply do it. Here I'll just give us a quick demo of what we have. So just to show you how easy it is to install these Intrepid Python library type of things. So let me just simply open the command window. I just wonder, can you guys see the command? See my command window?
Yes.
Yes.
Yes, we can.
Yeah. Thank you very much.
Yes.
Yeah. So I'm just simply this computer is my working my workstation. But before the training, I've already erased everything. So, well, before the training session, I've already got the Python installed, Python pip, and I think that's pretty much all you need. And then you have a command window. You just simply run this pip install, and from HTTPS site. So just simply do that. It's quite easy. And you can't have wheel, these wheel type of things is an optional thing. If you don't have wheel, it will just simply run an old setup.py. So you can see here, it successfully installed this Intrepid Protobuf and Protobuf 3.12.2. So this Protobuf 3.12.2 is the library from Google. And Google put this in a pip repository as well. So you don't have to do anything with the dependencies. Pip controls everything. Yeah. And here, if we wanted to do something like, say for example, we want to run let me just find the directory where I have, oops. They closed the directory for me. Geez, please. Yeah, okay. So, well, the whole design principle of the Python libraries is to make it extremely easy to use. So, yeah, I don't have. Oh yeah, sorry. I want to add Mark here. I want to join us. Yeah, sorry. I think it is. Yeah. Now let's go to. I'll probably shut this down. Let me. So this is check reading. Close it. I actually want to come up. This is project manager, which is good. And so from project manager, you open the command window, and this command window will set all the pathing and the environment variables. So have a quick look on what we have here. This is an example of this Epicola project, and we got a clip.py file already pre-cooked here. And so it's just simple. You can just simply run it by using Python, Python .py, and it just simply, it return automatically. Yeah. So let me have a look what we have in here. We better. At least there's no error message. Just editing clay files. If I run it, I should have something. Oops, it didn't show any. Oh, sorry. I'm not going to run a device session here. Sorry. Yeah, but this is a general idea. Where, as soon as you got a Python file, a Python script, and you can just simply run it from command line. It's pretty much the same as running, this F manager type of things. Yeah, I think there must be something. Yeah. Oh well. Sorry, I'll just move on. Okay. Yeah. So as I said, well, the library itself is not mandatory. You can build the Python bindings by yourself from a Protobuf file. And oh, sorry. Go back. And the executions. So you don't have to run the executor, run our default executor. You can run your own executions. So because the whole task system, the batch system, is driven by a distributor called F manager. So you can build your own message and throw it to process it, and then throw it to F manager. So you can imagine, have an executor. You can build a very complicated executor using a DAG style computational graph based parallel executor. You can build it by yourself, but we are working on providing a more complex executors. Yes, that's. Well, once you start to write a Python script, and to follow the Google Protobuf's Python encoding is important. So here I provide a link to the Protobuf's main website, where it has a Python basic tutorial, which shows you how to write a Python script to play with your Protobuf messages. And these Intrepid batch system and the Python bindings, this is one of the most rapidly evolving area in Intrepid for the moment. And we're adding more functions to it. So we're adding binary support, we're adding the JSON support, and we're trying to make the Python bindings and the Protobuf definitions more user-friendly. So for example, to provide some feedback on the progress, error reports, and to help you with that. So there will be more documentation and examples, and currently there are a few examples in the shipment. We have a lot of task files but I simply need more time to convert those task files into Python scripts. So later we'll ship all the Python script along with the tasks. So you don't have to write the tasks by yourself. Just simply run the task, write the Python script. And we made this Python bindings our first citizen in our technologies. It's now one of the core part of everything. So this is a guarantee, to have fully support by us. And if you start to write the Python script today, or you start to write tasks today, it is guaranteed in the near future, if we change the definition of the messages, and we will provide you a tool to convert your script and task files to the new version to make it backward compatible. And if you need any help, you can talk to us. So there are two places. One is you can send an email to us through support@intrepid3d.com, and the second place is this GitHub project. So you can bookmark this and watch this project and to see what's the latest progress with that. You can issue report against it. There's no problem. And also in the Intrepid Protobuf, in the Intrepid JF Manager, I think probably George showed this already. In the help menu, there's a Protobuf documentations which shows you the Protobuf definitions as a reference. So when you write your own task files or you write your Python scripts, you have to go through the well, in the very beginning, you probably have to go through the documentations. So the last one is the last two. I provide two links to the Google Protobuf website. So if you are interested in the protocol buffers and how it interacts with, say, for example, other languages, C++ or well, Java. For Java libraries, we can probably provide the Java libraries with our product. And for C++, I recommend you to build your own, because in this case, you don't have to use the same compiler as what we do, and due to the ABI compatibility, and you don't have to link against our libraries. You can build your own C++ bindings, and these two websites, these two links shows you how to do that. And if you have problems, you can get back to us. Yeah, I think that's pretty much it. So, any questions?
Yes, Diffu.
Yeah.
I'm just wondering if you've got some examples like you do for the task files for running different tools in Intrepid,
Yeah.
or is that part of the documentation you mentioned that's online?
Well, online, there's a GitHub project, but this GitHub project currently hosts all the Protobuf bindings, the Python bindings, and the executor. It is a very simple executor, so it just simply does the job, but there's no examples in it. We ship two examples in our examples area with Intrepid. So one is this clip line thing. Yeah, I have to probably do some debugging, see what's going on with that. And the other,
I think I found that one. So that's the clip _ ebagula.
Yeah.
Yeah.
This is the PY, the Python script where you can use. Yeah, and I think there's another one in the shipment. Let me just. Okay. We just randomly picked two. Oops, there's only one.
Yeah, I think I could only find one example.
Oh, okay. Yeah. Anyway, I'll add more examples to the PY, because this the Python thing is new to us as well. And before, we just try to handle the task files, the test files, and in our code we use we do not use Java Python bindings that much. We use the Java bindings, and we use C++ bindings most of the time. And so these Python bindings will gradually add more examples to the GitHub project.
Yeah, that's fantastic. I personally would find a few more examples really helpful. I'd love to
Yeah,
use
exactly.
Python to run some of these tools.
Especially, especially I think it's important to show you guys some examples with, to replace those repeat blocks and that kind of things. With some fancy use, the string substitutions and define variables, make it a little bit more complex. So this clip line thing is a very simple example, but I guarantee you there will be more examples.
Fantastic, thank you.
Yeah. So well, if this is the thing, I think because everything is online and you can play with that. Probably after today, I'll just simply go back to my C's and see what's going on with these Python bindings. And this is a little bit unexpected. But anyway, just keep in touch. And if you have any feedback or any requirements, any desire, let me know. Okay, I'm open to all these sort of new ideas, and we'll try to improve that in a make it better. Okay, thank you very much. I'll probably give my time to Reading, and Reading's topic will be on grading and grade up. Yeah. Thank you.
Thank you, Diffu.
Thank you very much.
Hey guys, how's it going? I just need some time quickly set up, and then I'll begin. Sorry about that, everyone. 2 more moments. So welcome everyone. This is the 2 seconds. This is the training for our Intrepid gridding. My name is Ridden Byrne. I'm a test engineer here at Intrepid, background in physics. So for geophysicists, moving geophysical data from line or point to grids is a fundamental process. And the Intrepid gridding tool is a powerful tool that allows that to happen. And the tool itself can support point line data, as well as scalar and tensor data. And it can be in varying density or sparsity. So if we have point data that from multiple surveys varies in spacing, we can support that as well. So today I'll go through a demonstration of scalar data, tensor data, and variable density data, if there's time allowed. So the standard procedure for Intrepid gridding, or the standard workflow, we'll take an input data and in these fields, you'll be able to specify a gridding method, then a gridding refinement, if you so wish, and then you can specify the output file as well as the cell size and the extent of the grid. So, and this allows you to create grids using a minimalistic curvature refinement. By cubic splining, you can use Falcon or FTG data, and it does allow to create grids from many data sets or large grids in a tiling method if it's needed. So that saves on memory. Today, the scalar data demonstration will be using an Albury dataset south of Wodonga. It's one of our shipped examples, and it's part of our documentation, our guided tours, and our cookbooks. We'll use it. And our documentation can be found online. There's a number of cookbooks and guided tours that run through step by step on how these processes go. So this is the data that we're looking at. It's raw magnetic data, as I said, south of Wodonga. Line spacing about 100 meters. So we use a cell size of about 25, and we'll go through it. So the standard workflow for a scalar data grid would be to specify the X and Y that we want to use, whether that be geodetic or projected data on a UTM. And we specify which data field we want to grid. In this case, we'll use the gridding method of nearest neighbor, and we'll set an extrapolation limit to 5. And I will explain why that extrapolation limit of 5 is used. And we'll finally specify the output grid file name, and we'll set the desired cell size. It's a good thing to note that a 1/4 line spacing acquisition line spacing or separation is a really good basis for the cell size of the data. And that's just a simple diagram in the bottom here that demonstrates why this allows you to, the cell size is chosen like that. Of course, this is a very perfect scenario where you have nice straight lines and clearly spaced points. But it's something to consider. So begin the demonstration with the Intrepid tool. So our data is in the sample area. So we'll head into the sample data to guided tours, to our Intrepid databases, and we'll look at Albury. This is the Albury data that we wish to grid. So we'll select it and head to our gridding tool under the gridding menu. And with it selected, it'll automatically open into the tool. Because the tool already knows that the X and Y field is set, it'll automatically populate those two. And then we just need to choose our data to be the raw magnetics. Next, we choose to acquisition lines are detected by the line type, and this is a true or false field, a Boolean field, where a value can either be a 2 or a 4. A 4 would indicate don't want to misspeak here. A 4 would indicate a tie line, and a 2 denotes a traverse line or an acquisition line. So this is how we identify our tie lines versus traverse lines. And we don't want tie lines in our data because it can cause spikes and pimples at the point that they intersect. So we do want to remove them. Next for this, we'll choose a gridding method, and we'll specify an extrapolation limit of 5, and we'll use a nearest neighbor gridding method. We then move on to our grid refinement, and we'll leave these values here as the default, but we do have an option to modify the number of Laplace iterations, which are a fast pass initial kind of smooth made to adhere to the Laplacian nature of a field. And then we also can have a minimum curvature number of iterations. So this will go through 100 times on the grid and smooth or iteratively. Each time the change it makes will be smaller and smaller on cells until it gets below a maximum residual, or it gets to the 100 limit and stops. You can also specify an extra smoothing iteration on the final grid. And we can choose to fill the holes internally if your data has holes, and you can set the edges of your grid. So you can choose to go to the extrapolation limits, you could adhere to the original data limits, or you could strictly extrapolate cells. So this means that on the edge of the cell, you would go 5 further. I then head to the output grid, and for the most part, the values are default. We're going to export to the Albury_raw mag. It's set automatically. It chooses the input field or input file and the field that you're doing. And so this is a very simple naming convention. And in this case, we're going to drop the cell size down to 25. From here, it's just a matter of pressing apply and waiting for the file to finish.
Can I ask a question at this point?
Sure, yeah.
So how do you know that your origin is set up so that your example that you gave on the first slide about the cells being distributed across the line, so you have 3 perfectly in between the lines with the cells sitting right underneath the lines, how do you know that that's been
As
done properly?
the diagram earlier was a very perfect case. That's not always the situation. There's going to be some variance. You know, some line spaces are going to be 80 meters, some are going to be 120, and so the data point is not always going to be at the centroid. The origin's never going to be perfect.
And if we go back,
sorry.
if we go back to grid refinement,
Yep.
the grid refinement tab, what's the difference between kernel size and what does your relaxation factor do there?
I'm not going to be covering that today. It's not something that I'm particularly knowledgeable on. This is a question that I'll have to bounce to Des if you would like me to get back to you on that.
That's all right. And I have noticed that I have run tests with setting the edges for the fill holes, setting grid nulls and fill holes, and I set the edges to extrapolation limits, strict extrapolation limits. It chose all the different options, and I didn't get any different results.
Right. That would require, I would have to see the data to understand what perhaps is happening there. I have seen with some of data sets, at least in sampling and testing, we have a difference between strictly adhere to the original data limits and to it go beyond to the extrapolation limits. So there's a bit of padding around the edge of the grid.
Okay. And see how you've got a whole, you know, the survey area we can say is rectangular, but
Yep.
the western edge of the rectangular area has a large gap in it.
Yeah.
What parameter would you choose to fill that gap completely, to fill in the whole rectangle?
You could choose to go to the original data limits. If we try that with the fill holes and an extrapolation limit that's large enough, so we'll head to 10. We'll begin seeing that area become filled out. So it slightly became a bit more filled out each time. And you would have to go through over and over again to make sure you have enough cells heading up in that direction. Otherwise, you can choose larger, again, with extrapolation limit as well, rather than adhere to the original data, and a similar thing.
There's no easy setting to just get minimum curvature to smoothly fill in that blank area?
There perhaps is within the task area. I haven't gone through and covered it myself. I would always go to where the data is. That's where we train. And as a physicist, that's something that I look into because the data is only available in that area.
Really, the reason why I ask about this particular case is that we found that when you do a Fourier transform in Intrepid, you get some quite nasty, you can get some quite nasty, you call it reverberation around the edges.
Yeah.
So by gridding a larger area, you push those edges further away from your data. So if you do get any problems with the Fourier transform, they're away from your data. You can clip it out afterwards.
Okay. Yeah, I can discuss with Des. We can work out a workflow there. Tomorrow we are covering grid filter, so that will go into the Fourier filtering and how the padding works in that tool. There's a large number of padding that's applied to the edge of the grid, and that can be controlled for our filters. So that perhaps will be relevant. We can discuss that tomorrow.
Thanks.
So heading off from here, we do have the original grid that I can showcase in 3D Explore. But instead I'll actually just go through and I'll modify a task file to save a bit of time. So I have the task file here that I'll show you in VS Code. So you can see in the text editor what the task file is doing. And in this case, I think George perhaps would have covered earlier, and Diffu as well. But in this one here, we have a repeat block. I think some of you will be familiar with it, but we go through each field in the database and we grid them. Just for the demonstration, though, I'm going to remove the majority of them, just to speed things up. So I save this. Oh, sorry. And I actually changed the extrapolation limit to 3. I just want to demonstrate how the internal lines are being filled in. So if I run this task now, or I open with task even, it's now supported in gridding. It's going to open the interface with the settings that I've chosen. And it will allow me to then modify anything that I see fit. So if you had one process that has worked in the past, and you can open it again, modify what setting you want to change, and then press apply. It's a nice filter for a nice feature for repeatability. And this is what I wanted to demonstrate. With the extrapolation limit too low, we do get these lines of missing data where it hasn't been interpolated across, and it's not really a cohesive grid. So the next demonstration, after having gone through that, we're going to look at some tensor data and how the interface of the gridding tool changes when we look at tensor data. So I'm going to close these two other ones, and I'm going to head to the cookbook area where our tensor data is. And before that, I actually want to go back to demonstrate some other things, sorry. Yeah, so tensor data is capable of processing Falcon, full tensor gravity, and tensor gradients in Intrepid. And the gridding of tensor data does differ to how we grid scalar data. So instead, a different interpolation method is used here at Intrepid called SLURP. It's spherical linear interpolation, and it adheres to the rotational properties of the curvature of the grading of the potential field. That's quite a mouthful. The benefit of using this method is that the cell size can be taken smaller because you have more constraints to make on the data, and you can more confidently interpolate between points. And I'll be demonstrating that here. In our tensor gridding as well, we do have a noise reduction method, MITRE, and it does remove speckle away from the grids when after they're produced. And it's based upon a linear relationship between the third order components of the fields. So there's a demonstration at the bottom, that, an equation of the proportionality between the components. So if I head into Intrepid now, and into the cookbook area, there are two tasks that we can run using OpenWidth. So I head into full tensor gravity gradients. Montezuma is the area that we're looking at. And there are some task files here that are demonstratable. There's actually a number of task files for each area of the cookbook. So we have some tasks here. We have a grid with tensor, and we have a grid with a rotated field as well. So the first one I'll show is the MITRE process. And I'll open that with the task, and the interface will populate with all the data ready to go. So we are gridding the X and Y fields and T, FA, and FTNR. The gridding method we use is nearest neighbor, but behind the scenes, that is the SLURP that I discussed earlier. The grid refinement, we don't do any Laplacian iterations, and we only do 10 iterations of the MITRE process. With a kernel size of 49, this can be taken down to 25 or 9. And we set a maximum residual, and it's dependent on what our data is. Our output data recognizes that it is a tensor data. We can choose a cell size of 40, and we can then just run the process. And because it's a larger data set and it's tensor, it takes a little bit longer than the scalar data. And it's going to be one moment. Excellent. So there it's finished. And this is a tensor grid, so we actually can query the components. If we head into the file and look at the thumbnail, we can just quickly demonstrate that it is queryable. There's a number of components here that are saved or calculated from the file itself. So we can look at the full tensor. We can look at the tensor ratio or the tensor trace, for example. The next process would be the rotated grid. So when you have grids that have rows and columns rotated, Intrepid gridding can support that and create them even. So we'll head to the grid tensor rotate with BiSLURP. And we'll open that with task.
Sorry, what do you mean rows and columns rotated?
This is something that was a new concept to me recently. I had to took me a bit to understand it. Rather than having the rows and columns directly horizontal or vertical, we store them slightly, we'll tilt it and rotate it so that when they iterate over, they're going on an angle. So the data itself still appears in the standard spatial orientation that we expect it, but the rows and columns are at an angle. So what happens is that if we had lines that were recorded on a bearing that wasn't directly north, directly south, or directly east, instead on an angle. When you grid them, all of a sudden we're looking at data that is going left to right, up to down, which may not respect what the data originally was doing. So we rotate the rows and columns to adhere to that. So that now if we do a process over the grid, they follow where the lines originally were. It's just a matter of respecting the original data and adhering to it in case there's any artifacts or any conditions that might appear because of it. So I've opened up the, sorry, does that clarify? It's something that's covered in our documentation. And I can demonstrate tomorrow, in fact, in grid filtering if you would like, if you're attending.
So does it, yeah, okay. So it rotates it in one direction and then rotates it back again after some process has been run?
That can be one of the cases, or it just the way the data is stored is rotated so that it knows that rotation does exist in the original line direction. Because when we think of grids, we do think, nice squares, always straight, not really pixelated on an angle. So it's a matter of how the data is stored on our end. It doesn't necessarily affect how the grid displays when you are looking at it or producing it.
Okay, yep.
So this is the rotated grids here. So we can choose to specify our acquisition lines by bearing. So in this case, we do have a situation where our data was recorded on a angled flight, not going directly north, south, east, or west. And you can choose to calculate this as well. And there's a method for that. And for the most part, it's going to return the same answer. The gridding method here is by cubic spline, and we'll choose a spline type of Akima. So the number of different algorithms, and they are covered in varying detail in the documentation. And there are obviously resources elsewhere, because these aren't necessarily just our methods. Grid refinement, we don't do any for this situation. And our output grid, we are looking at tensor data, and we have a rotation of 67 degrees. So there is something to consider when we're looking at these to remember. Obviously, it's a full circle. Sometimes the degrees are relative. So we have a case here where the rotation is 67 in this window, but previously the bearing was 157. So it's something that's held, that needs to be looked into and cared after, because if you make a mistake here, it can have an effect. And we apply and we run the task. And because it's a rotated grid, it takes slightly longer, but it's finished now. So in this case, this grid has been rotated, so we can think that the cells are heading, when they're indexed, if this is row 0 where I'm at, row 0 would also end up here, rather than come across the horizontal, it would come across where the data lies. It allows, it again allows for gridding processes to happen on data that honors the original. After demonstrating the Falcon, we'll take a look at actually what the MITRE achieves. I'm not going to pull it up in 3D Explorer. We take a bit of time, but instead I do have an example here. So we have...
sorry, that rotated grid, so just ask a quick question about the rotated grid.
Yep.
That means that if you were to do a decorrugation process or some other line, rows and columns based process,
yes,
the tool would know that's a rotated grid, and
yes, yeah, it is.
Okay, thank you.
Same with, so it works if you have, it would know it's rotated grid. So if you're doing differences or decorrugation, it will run along where the rows are. That's actually a really good example. So thank you for bringing that up. I hadn't thought of that just yet. Yeah, decorrugation is a use case there. So yeah, back to MITRE. We're looking at the speckle reduction or the removal here in the tensor grid. On the left here, we have no smoothing or no noise removal, and on the right, we do have the noise removal. And this is conducted adhering to, the MITRE uses 3D gradient physics of tensors to minimize parts of the tensors that don't observe what the physics should be in those locations. And this is looking at the gradients. If time is permitting, which I believe it is, yes. We can take a look at variable density gridding and how it's done. Do keep in mind this is a very simplified approach to a problem that's been in the industry for quite some time, and it's still in discussion today when we're talking with other geophysicists on how this procedure should be done, how it isn't done. So yeah, I'll head into it. Just something to note that the result of this product here in Intrepid is slightly different to a method produced for South Australia by Laszlo for the supervised variable density gridding. So they have a very similar process, but it produces a result that is smoother. And it's a matter of opinion whether or not the smoother is a good thing for the data or a bad thing. Whereas here we do honor the original data, and it does mean the data can be pimply if we're looking at older data that differs in the quality that they're recorded at. So if the original quality of the data is bad, we shouldn't expect our grid to be excellent for sure. So the variable density gridding, if I should clarify, is looking at gravity point data mostly that differs in density. So we have surveys that are recorded at 2 kilometers and surveys that are recorded at 10 kilometer points. And it's a way of stepping through those and getting a nice cohesive grid that does have variable cell size. And it does so by using a reduction factor. In the Intrepid interface, we have a reduction factors that we can select from, or you can specify your own task syntax. And what it achieves is that if we have a survey where we want to have a 600 meter cell size and our largest is 3600, we can step through with a reduction factor of 2 or 3, or 2, 2, 3. And what will happen is it'll grid at 3600 and then do the 2 reduction, grid at 1800 meters, and then the reduction of 3 and grid it at 600 meters. And it will only do so where it's applicable. So it's not going to step it beyond and extrapolate beyond its data limits. It is safe, I suppose. It respects the data, it adheres to it. So if we want to have a look at the interface when we do variable gridding, we head into the cookbooks to the continental scale area. So I'll open that up now. So under our cookbooks, we have a continental scale, and this is looking at data at a continental scale. And the data we're looking at is the Northern Territory Gravity Survey. So I head into gridding again with the data selected. And I choose to just grid the free air in this case, whichever it is, depends on what you want to do. We're not looking at any acquisition lines because it is point data, and the system does pick up on this. If there is no line type specified, the gridding window is not going to offer that as the default. The gridding method we want to use here though is the variable density. And here we can specify the reduction factors that we want to look at. There's a number of them. Intrepid only offer up to 3 in the window, but you can offer up to 4 in a set. And that's just specified in task file syntax. And if you're familiar with coding, it's just a list structure. It's the same way you specify a list in Python with square brackets and commas. So it's rather easy to do. An important note though is that if you do want to specify your own, it is a reduction factor. So the list is read back to front. So it might take some iterations of testing before you go do a large job, or it could go the wrong direction. So for this time, we're going to do 2 and 3 to save time, and we'll leave the other settings as is. We won't change any settings here either, and we'll head out to our output grid, and we'll leave the cell size at 600 meters. We want to specify what our, this is geodetic, right. Apologies. I expected this to be projected data. I had forgotten that I needed to reproject it, so I won't be able to run it today. Instead, I'll just run it with the default settings, and it won't be perfect, but it'll be a demonstration at least. So, sorry, head back to FreeAir. And something I'd forgotten to mention, the variable density, we can choose to save the coarse grids. So the intermediate files between, we can have a look at them and see what they look like and what cell size they're at. And this is just a prepended, or the base name for it. So it's going to add some extra things to this to make them differentiable. Well, differentiable. We can see that they're different. And we apply with the default settings. So we have here the outputted grid, and we can see that there was a single grid produced between it. And this grid here was made at a cell size specified in degrees, and the final grid itself, my eyesight's not playing up, we specify a different cell size again. So there is a difference here of half, approximately. Yes, half. So we use a reduction factor of 2 in that example, because I didn't change it. What
another question, just another question about supervised variable density and Laszlo-Katona's method.
Yes, yeah.
I have heard a rumor that Intrepid are working on implementing that Katona supervised variable density method. Is that correct?
We're looking into it. We're looking at ways to replicate it here at Intrepid, so we can offer both our method and the alternative method. Portions of the South Australian project that brought it to light did use Intrepid, so we see fit to make sure the whole process can be done as well within Intrepid. I'm the one that's looking at that initially as a bit of a training exercise with assistance from Des. So that's something we're working on. For your information, the task file portion that was previously with others in job files has been completed, so I can get a portion of the task to run with our task syntax, but there's still some issues in development that needs to be made for how we cluster and qualitatively take a look at the data. So there's a way you cluster data by then how close they are to a neighbor and their quality, and then draw polygons around them if you're familiar with the method. That's something that I'm looking now at how we might be able to achieve here at Intrepid. The later part of the process where we actually grid iteratively and remove the data if it exists within a polygon has been automated already. But yeah, so that's an interesting development that we could see to happen in the next few months. Sorry, we're back to my point.
Thank you.
Yeah. We're going to look at the variable density here, and we'll be able to see the change in resolution of the cell. So we can see a change from blurry to clear, depending on what was allowed. So I bring this full screen, and we zoom in here in this area here that I know is closely surveyed, and we can see that the data itself does seem clearer, more concise. Whereas in these regions here that I know haven't been, if you can see my cursor, I'm assuming you guys can. You can see that it has blurrier or more blur to it, I would call. This is low resolution. So this is an example of how the cell size changes across it, across the data, across the grid where it's applicable. So we do have a combination of fine and coarse gridding. And that's achieved very simply through the gridding GUI. That basically concludes the gridding demonstrations. There's another example again of the data. This is the data that's gridded at 2.3 reduction factor. So we have 3 types of gridding cells, of cell sizes here. And that will conclude my gridding presentation. If there's any questions, I would like to hear them.
Yeah, can I ask a question? The variable density gridding, so say we've got a mag survey and another mag survey next to it, and there is a small area of overlap, and we merge those 2 databases together to be able to do this process. Yeah, will that create problems in the area where there's overlap, or is there a way to deal with that?
There are plenty of ways to deal with that. A situation with mag data, is it line data or point data? Yeah,
line data.
Line data. So you can merge databases, and you could assign a quality to the area of the overlap. So you might say that one survey was recorded in 2010 with an old magnometer, and new one's recorded in 2019, and we'll just say the 2019 one's better. You could have that as the higher priority at the point data or line data stage. Or alternatively, you could grid them separately and bring them together in a grid merge. That's probably the more traditional method here at Intrepid. But there's no reason why you have to go to grids first and then merge. You could always merge from the point value. There can be some issues with overlapping data, especially here in the variable density. And it's something that we need to address. When you have old surveys that have points really close to where a new survey is, and the values differ substantially because of old recording practices where barometric pressure is recorded differently or any number of terrain corrections have changed. You get some pimpling where a minimum curvature cannot possibly adhere to both points. So what happens is the system says we should honor both points, and you get this horrible looking artifact. And the way we address it is to say the old data has been overruled by the new data and just get rid of it. So it's a matter of designing a practice that is suitable and feasible. But there's a number of ways and pathways that Intrepid could offer for that.
Okay, because I'm just asking, so the actual variable density gridding routine has no way of sort of solving those problems. All it's doing is subsampling the data and then regridding it at that higher resolution, isn't it? It's not actually doing anything smarter than that, is it?
No, so that's where the supervised variable will differ, because you can remove data and you get a smoother output. Whereas in our method, when you have lines that are close, it's going to create an issue if the minimum curvature cannot be adhered to. It's going to cause a visible artifact. If that's the case where your data differs slightly. Or it could be the case that the data is a good match and that they work well. But there are a number of workflows that can be done for that type of data in Intrepid. And there's a good number of examples of grid merging as well, which will be showcased tomorrow, and I'll be doing that.
Okay,
cool.
Thanks.
Any other questions? Perhaps not. All right. I think that will conclude that. Well, that does conclude today's training. I'm the last one today, and tomorrow there will be grid filtering, not grid filtering. There's gridding operations, grid merging, and I believe some line filtering and grid filtering from Tim. So hope to hear from some of you all tomorrow on that. And thank you very much for listening.
Thank you.
Thank you.
Thank you.
Cheers.
Thank you.
Thank you.